So 1, 3, here we go. We're talking about comparing numbers and ordering numbers. So you started to compare numbers at a very young age. I don't know when that was, early elementary school, maybe even kindergarten. When you got to 7th grade, we definitely continued to do this together. Anytime your math teacher tells you to compare, you have 3 options. What are your 3 options if your math teacher tells you to compare something?
Less than, more than.
Yeah. So, which of the signs is that one?
It's less than.
Oh, it's right.
More than.
That is the greater than sign. If you think about putting some numbers in here, I'll drop you an 8. Drop me a number there that makes this a true sentence.
4.
4. So, you know, your elementary school teacher talked to you about alligators, or they turned that into like a Pac-Man drawing or something, that the hungry creature is eating the bigger number because he's hungry. But 8 is greater than 4. If you're not sure because you forget the symbol, try to fill some numbers in there. It just makes it a little bit easier to decide. That one is our less than sign. This one is equal to. And you're at an age now where tomorrow I prefer when we go through the answers, if we go your turn, your turn, your turn, that you're saying greater than, less than, and not everybody's going this one, that one, it's this one, it's that one. And everybody has to like turn and look at you when you're holding and saying this one, but we just kind of absorb it's less than. So the homework is, a little bit of the homework is going to have just straight up a couple compare questions. It doesn't really get too taxing until they throw fractions or something at you. So if I throw fractions at you and want to compare, what's a way you could compare fractions other than 50-50 guessing, or other than trying to pick, like visualize a cake that's cut in 3 and you get 2 pieces, or visualize a cake with 5 and you got 3 pieces. That's a tight call. Those are both pretty much like more than half the cake, but not dominantly.
Can box the top?
We could, yeah, we could go ahead and divide the bottom into the top, and we could make those decimals. That's 100% true. I'd be totally on board with that strategy. I'm going to do it a different way, but absolutely 100% correct. You could absolutely do it that way. Another way we could go and compare these, other than making them decimals, we could do a common denominator. And I think people probably would rather make common denominators in terms of speed than long divide. Sometimes when you start to divide those, it goes, it goes, it goes, and goes. These wouldn't be bad. Those would both be quick hits. But what would you pick for the bottoms of 3s and 5s? 15. And if you're going to multiply the bottom, you've got to multiply the top. So this turns into 10. This turns into 9. So the winner is the 10, the 2/3, the 10 thing. Question about that? If you did divide, anybody remember 3/5, what it goes as a decimal?
6.
It is a 6. How about the 2/3? 6 that repeats. So 6 that repeats beats a 6 that doesn't repeat. If that's quicker for you, use that. I have no objection to that either. Question there. Okay, 2/3 competes with 5/8. So common denominator? 24 is true. New top where the 2 sits? 16. New top where the other one was? 15. Why does 16 not beat 50?
Because it's negative.
Because it's negative. And in negative territory, the roles are all reversed. The bigger number in value loses. 16 loses to 15. So that's another greater than. Because negative 15 is not great, but it beats negative 16. The negative, it's the opposite relationship. Question about that? Another game they'll play in the homework, and they actually do this in the homework first. I'm not sure why. This seemed easier than that, but hey, they wrote a book, so we don't get to argue with them. They're going to do like a triple, quadruple, quintuple kind of compare problem where they'll say list these in order. The directions also say to do a number line. I don't care about that. Skip the number line if you want. But I just want to list these from the littlest to the biggest. Put them in order from lowest to greatest. So if I were going to reshuffle this list, Who's the lowest number?
-6.
-6. The biggest number?
5.
5. So I would need to reshuffle this list and throw 5 at the end, leave 0 in the middle. There's a list where they're in order. Question about that? So if I go to take this one on, who's the lowest number of this list of 5? -1 is the lowest of that list. Who's next in order if we're moving up in the world?
-0.5.
-0.5. Because 0.5 would be somewhere between 0 and 1 on the negative side of town. Who's in the middle of this list? 0. Is that positive or negative 0? Neither. It's in its own club. 0's there to just cut this into 2 worlds. So then we're down to 1 or 1.5. 1 goes next. 1.5 is the biggest. Question about doing the put it in order game, which is kind of like the same game as comparing, just with a bunch of numbers all at once. The third thing that we're doing, which is more of what the homework is going to contain, the third thing is not big. Fourth thing is where it gets big. Third thing is just a little thing, is they're going to ask you what the opposite of certain numbers is. So if I ask you the opposite of -8, there's 2 things that are a reasonable guess. +8 is the correct guess. If you had said 1/8, I could have seen that also, something about 1/8 in that family, but that's not what they're after. The opposite just means that you're going to do what? Change the sign. In other books and places, sometimes this is called the additive inverse. And if they want to use symbols to do this, instead of writing out opposite of, they can just put this symbol and then -8. So if they say opposite of -8 with words, or if later in the book they just do this symbol and then -8, either way, we're turning out that 8 that we just said. So whether they use words to say opposite of +4, or whether they do this symbol and then +4, either way, the opposite of +4 is -4. This connects a little bit to the subtract rule that we've had in our past together of minus minus makes plus. 2 minuses in a row generally turns into positivity. Question about that? Absolute value. Anybody know anything about what absolute value is? I don't think this came up in 7th grade, other than in worksheets in the back of the room if people worked independently at the end of the room. This would have been more of a pre-algebra, algebra 1 thing where you start to see this for the first time.
It doesn't matter what the sign is, that number will just be 4.
That's correct. The absolute value of -4
It's 4.
is 4. Absolute value I could define as the distance from 0. So how far a number is from 0, that's its absolute value. It's never negative. It's not quite true to say it's always positive, because who's the forgotten number that's the exception to make 0? Absolute values of 0 is 0. But the absolute value of every number other than 0 has to turn out positive. Absolute values are never negative. They're almost always positive, but I can't say always because 0 causes a mess for us. So absolute value of +4 is 4. Absolute value of -3 is 3. Question about the basic life of absolute value? Somebody close, if you can rotate me a little bit. Just make sure we can see the end of the board. We good? All right, thank you. So here we could have a difference of opinions. Some people might think 3. Some people might think -3. Somebody who hasn't done this class before, do you have an opinion on whether this should be 3 or whether this should be -3?
-3.
-3.
Darn. Hey, you know what? I tried.
Can anybody who either did or didn't do this class before explain why is it -3, not +3? The argument for +3 would be minus minus makes plus. We just talked about that. But that went out the window here.
The reason why is because absolute value only affects the numbers inside of the two parallel lines.
That's
so that
true.
would make it 3, and then the lines would disappear, and so the negative out front still stays negative.
That's true. The bars would zap what's inside to make it 3, and then this would attach on to make it -3. In a sense, the bars act like what other thing that you've seen before in terms of they do things first. Parentheses. The bars act like parentheses in that you do the stuff in them first. So these are going to take us to some different places now. So for this problem, you're going to need to do the adding first because it's in the bars. And then wait for the bars for later because the stuff in the bars happens first. These, you would do the bars first to zap the numbers inside, but then the adding comes later because the adding's not in the bars. The bars are like parentheses, you do that piece of the problem first. So anybody an opinion on this?
10.
It is 10. The bars would zap this to make it 3. The bars zap this, makes it 7. Then you do the adding, the 3 and the 7 that have been zapped, and you got 10. Would this still be 10, or does me changing a sign make it go somewhere else?
It's still 10.
It's still 10. Because these still are going to get zapped into 3s and 7s before you go ahead and do the adding. Question about that? If I do this, or if I do this, or if I do this, or if I do that, did any of those things change the answer?
No.
No. Change the problem, but the answer remains the same. This, maybe this is a 10, maybe this is a 4, okay? But this is a different thought pattern. These were bars first, then add later. This is add first, do bars later. So if -3 adds 7, we're thinking 4. Then we think bars.
4.
Still 4. Question about that? So this time, if I start changing these signs, is that going to change the answer? No. Yes, it will. Because if I made this +3, now we're looking at
10.
10. If I made this a -7,
It would be
we'd get -10 for a moment, and long term,
negative
the bars would zap it. -10 would become 10. Question about the bars? So here, minus minus to make plus, is that what we're doing?
1.
No. Do the bars, zapping numbers, save the subtract for later.
3 minus 8.
So we go regular old 3 minus regular old 8. -5. I changed some stuff here, but did I change the answer, or is it still sitting on the same answer? Same answer. This is still going to turn into 3, that's still going to turn into 8, that's still going to be -5. How about this one? Still -5. How about this one? Still -5. Those are all going to turn out the same way. Is this still the same thing, or we have to rethink?
Rethink.
We got to rethink. So bars are going to happen later. Do what's inside them first. So we've got a subtraction here. Subtraction. Minus minus makes plus. -3 adds 8. 5. And then the bars?
Still 5.
Just stay 5. That was fairly useless. This is the same piece inside. The difference is I did this.
So it's -5.
So it's now going to be -5. We'd have to do all the same work we just did, and then once we're done, remember, hey, that was there, tack it on, basically. Question about any of that? Basically, if there's a negative in front of the problem, think in terms of this. A negative out in front of the problem means it's an opposite kind of problem, or an additive inverse problem. It means you're going to have to change the sign to finish the problem. Not to start the problem, but to finish the problem. If it's got bars, you do like parentheses, do what's inside that function. think that's all that there is. Let me take a peek at homework page. So we're up to page 15 is where we live. And it's going from 1 to 24, skip a few, try 26, try 34, and that's the end of the line. One thing I see that you've maybe never seen before, I think you've seen before, parentheses, inside parentheses, inside parentheses. That's not, I don't think, news to your life. If you see those, where do you start?
The smallest parentheses.
Way on the inside, and you gradually work your way out. What this book chooses to do sometimes, because they find that like a little bit dizzying, sometimes they'll trade one of those sets of parentheses for a set of brackets that look like that. They still are just parentheses. They're just doing a different appearance, so it's a little easier to see that these are a set and those are a set. And then when they keep going, sometimes books will use things like this as a third thing, which just means parentheses. These are still just meaning that things are parentheses, that's all that is. When you see those, that's always absolute values. That has nothing to do with parentheses. They never use this as a symbol to mix in with those. But I do see in the homework a couple times at least that the brackets worked in instead of the parentheses. But all that is, that's just parentheses. They're trying to make it a little clearer so your eye doesn't get busy looking at that and you're like, wait, who's going with who? It's just a little bit maybe more confusing to see all those parentheses. That's what we got. I have a review sheet I'll give you tomorrow, which is Wednesday. That'll be due on Thursday. Thursday we'll take a quiz. The plan Thursday would be quick, go through the review sheet and just take the first quiz of the year. It's basically like if you took the first 3 homeworks and jammed them all together. So take the page 5, the page 10, and this, jam it all into a quiz. That'll be a Thursday quiz this week. Yes, sir.
When do I get it? When do I have to get my book covered by?
Today.
Oh, okay.
I was just about to do that next. I'm going to cut the record and we'll do that exact thing.